Welcome to Matrices. We are going to start today talking about matrices, and what we're going to be doing is we're going to introduce matrices. We're going to learn about addition and subtraction and multiplication. Then we're going to move to linear equations and talk about them a little bit. Then we'll talk about simultaneous equations, and then we're going to cross back to matrices and see how we can solve simultaneous equations using matrices, and then we're going to talk about transformation. So the way the curriculum is going to be done, there's a marriage between matrices and linear equations. So we're going to be moving back and forth between the two. But for today, our objective is to learn matrix operations starting with addition and subtraction. So we're going only to do addition and subtraction of matrices. Now, to be successful, you have to be able to define what a matrix is in the first place. You have to understand what a matrix is, and given the data, you have to be able to create the matrix and successfully perform addition and subtraction on the matrices, first manually, and then you need to be able to do the same thing successfully using the CAS calculator. So let us start. Alright, addition and subtraction of matrices. In all walks of life, you actually have been dealing with matrices without realizing it. If you have used Excel, for example, or any spreadsheet, you actually effectively were using matrices. Even manually, if you're looking at a train timetable, or a football scoreboard, or a scorecard, or your examination results, or even if you're looking in a restaurant at the menu, you were effectively looking at examples of matrices. Anytime there is what we call rectangular grouping of numbers, there is a matrix. And it's called rectangular grouping because it looks like a rectangle. And a square is a unique case, special case of rectangle when the length equals the width. So if we look here at this example, this is a summary of cricket scores after 3 matches. So you went and attended cricket, and after 3 matches, each of the players, Smith, Brown, and Wynne, they had these results. So Smith had 10 overs, and he had 3 maidens, 2 wickets, and 35 runs, while Brown had 14 overs, 2 maidens, 3 wickets, and 29 runs, and Wynne had 9 overs, 2 maidens, 3 wickets, and 39 runs. So this is a summary matrix, and this one already shows the aggregated result. So in this one, it doesn't show you what each one of them had in each of the matches. It shows you the end result. So this is like a matrix that already had the addition done onto it. Okay. So if we remove the heading, which is the name on the columns, we had at the top their scores, and on the rows we had the names of the players. So if we remove those headers and we keep the text only, we end up with this array of numbers, but still divided into columns and rows. And if we go back, you see here what we have is If we do it on this screen, okay, if we were to create the matrix manually, then what we do is we have the figure column by column, then 14 in the line, and 3. We can go row by row, column by column, and we end up same result. 2, 2, then 2, 3, 3, and 35, 29, and 39. So from this table, we got this. So as you see, it is perfect here. Basically, that's our matrix. Okay, so that's exactly what we wrote before. We get it here. This is called a matrix. The plural of matrix is matrices. Now, we call this a 3 by 4 matrix, which means it has 3 rows and 4 columns. So if you are familiar with a spreadsheet, then this should become a second nature for you. And if in the unlikely event that you have never used spreadsheets, then what we're talking about is, when we're talking about the lines, the number of rows and columns gives the order or the dimensions of the matrix. So we do it here. So this would be this is the first row, second row, third row. This is the first column, second column, third column, fourth column. So like this is a column, and like that is a row. Okay. So if we look at this example here, we count them. How many rows? 1, 2, 3, 4. How many columns? Only 1. So this would be a 4 by 1 matrix. Now, a matrix with n number of rows and n number of columns is called an m by n matrix. Each individual entry in a matrix is called an element. So in general, the elements of a matrix are identified by the row and column that pinpoint their position in the matrix. For example, if A is a 3 by 2 matrix, then for the individual elements, the first one here is 1, 1, first row, first column. This one is 2, 1, second row, first column. Third row, first column. That one is first row, second column. Second row, second column. Third row, and second column. Right? If we had more, then etc. It would be the next column here would have been, if we had, let's say, 3 by 3, then this would have been A13, A23, and A33. Okay, now the elements of the matrix A are referred to as A subscript ij, where I refers to the position of the element in the row and j refers to the position of the element in the column. So A to 1 refers to row 2, column 1 position. Now, when we want to do addition and subtraction of matrices, it's the same as if you had 2 tables and you went and recorded each individual match, and you recorded the first one, then you had another record for the second one, and another record for the third one. So then you add them up, you get the final result. Okay?
So what we've been given here is the results of the 4 matches. Remember, before we had the results of only 3, and now we've been given the results of the 4th one. So this new one includes the fourth one and the one that had all three in it. So what we need to do is to add them like what we do manually. So we'll add 3 to 10, we get 13. We add 3 to 1, we get 4. So that's shown below.
So matrices wise, we write the first matrix and the second matrix, and then we add them together. Okay, so what we are adding, this is the final results for all matches. We are adding this one with that one here. Okay, so when we write that here, it's 10. If we go row by row, 10, 3, 2, 35, and 14, 2, 3, 29, and 9, 2, 3, 39. We are adding it to 3, 1, 0, 10, 10, 1, 2, 34, 15, 2, 4, 54. So here what we do is we add each element in the position, same position, we add them together. So this is in this matrix is position 1, 1, and in that matrix is 1, 1. So we add them together, 10 plus 3 is 13. Then 1, 2, and 1, 2, okay, means first row, second column, is 3 and 1, 3 plus 1 equals 4. Then 1, 3 and 1, 3 is 2 plus 0, and the last position 35 plus 10 is 45. So you keep adding those in the same position together as what you would have done with a normal table, and you get the aggregated result. So addition of matrices and subtracting matrices for that matter is something, once you realize that this is the same as adding tables together. So in the same position, don't forget to refer to the same thing. So like in the position here, which is there, the A11 position refers to the number of overs done by Smith. So this is like if you go rows column, it means Smith had 3 overs, okay, in that match. And then in the previous one, Smith had 10 overs in the aggregated 3 matches. So 10 plus 3 is 13 altogether. He had Smith had 13 overs. So its position has a value for a particular thing. That's why when we add the same position. So we need to be adding Smith's overs together and Smith's maidens together, etc. We don't mix and match. Okay, so if we wanted to subtract them, then the same holds on. Same position, 13 here. We'll have the 3 here. 13 minus 3 is 10. 4 minus 1 is 3. 2 minus 0 is 2. 45 minus 10 is 35. Okay? So you just, whether we adding or subtracting, you do that operation on the corresponding elements. And now that we learned about orders, as you see here, you probably already realized that we can only add or subtract matrices with same order, okay? Which means the same number of rows and columns, because it's like in the table, you need to have all the information there and you add them together or subtract them together. This is very important rule. So if you are given 2 matrices with different order, then you say we cannot perform the operation on them. Now, we have the commutative and associative laws for addition and matrices. We want to see uh, whether they comply or not. Let's see for commutative law. If this law holds, if they are said to be commutative, then a plus b needs to be the same as b plus a. So for example, addition in normal numbers is commutative because 5 plus 3 equals 8 and 3 plus 5 equals 8. Alright? Now, This is, as you've seen, like normal addition. So indeed, adding matrices is commutative. So whether we change the order of the matrix or not, we still add in what's inside. So it is commutative. Now, for subtraction, we can say when a minus b is the same as a plus, open bracket, minus b. So from the previous rule, since the addition is commutative, then subtraction also is commutative because you can write a plus minus b as minus b plus a, and a and b need to be in the same order. So also for subtraction, it is commutative. So the commutative law holds for matrix addition and subtraction from the same order. Now let's see for associative law. Associative law simply means you can do a grouping in different order. So what we mean is if you have a plus b plus c plus d, you can do a plus b first, then add to them c plus d, or you can group the b and c, do them first, then do the a plus d, or you can group the b and d, etc. Any combination. So it doesn't matter which order you do it in, you will get at the end the same matrix. So if the law holds, a number of matrices of same order can be added together any pair of matrices first. Okay, so you can do it in any order and should give you the same result. And the associative law for matrices holds. So you can do it in any order. And for subtraction, remember if we say a minus b minus c, it's the same as a plus, open bracket, minus b, then plus minus c. So you can group them in any order, the same as before, because now it's adding something negative. So it is exactly the same as before and holds. So the associative law holds for matrix addition for matrices of same order. So, and that includes subtraction as well, because subtraction can be seen as adding a negative number. Okay, now let's look at our first example. Show that the commutative law holds for matrices A and B. So that's the other thing which we implied above. Each matrix you can give it a letter number, and that's something we can do in the calculator as well. We store it as a variable. So the A matrix is this matrix, the B matrix is that matrix. So you want to prove commutative law, we add A plus B, we get the end result, and then we add B plus A, and we get the end result, and verify that they are the same. Okay, so let's do that. Okay, can we do it here? A plus B equals. So let's add them. 1 plus 1 is 2. Okay, let's go row by row. 2 plus 0 is 2. Minus 5 plus minus 4 is minus 9. Now, next row. 0 plus 5 is 5. Minus 1 plus 3 is 2. 4 plus 1 is 5. And the last row, 2 plus 0 is 2. 0 plus 0 is 0. And 3 plus 2 is 5. This is the result of A plus B. Now, if we do B plus A equals 1 plus 1 is 2, 0 plus 2 is 2, minus 4 plus minus 5 is minus 9, 5 plus 0 is 5, 3 minus 1 is 2, 1 plus 4 is 5, 0 plus 2 is 2, 0 plus 0 is 0, and 2 plus 3 is 5. So as you see, A plus B equals B plus A, then indeed they are commutative. So the commutative law holds. and that's shown here, exactly what we did. So you put the matrices in the right order. So here it's A plus B, so you put the A first, then the B, and you add them. Here it's B plus A, you put the B matrix first, then A, and you add them. And as we've seen, they are the same. So indeed, the commutative law holds. Now, the second example, we've been given matrices A, B, and C, and find if possible, and they are saying if possible because as you see, those three matrices have different order. Find if possible A plus B. Well, A and B are the same order, so we add them the same way. 1 plus 0 is 1, 3 plus 5 is 8, etc. We get the result. A minus B, we just subtract them. So for some values we might get negative, and we get this. And then they say A minus C. For A minus C, they are different order. So we cannot calculate A minus C. And now what we'll do the same operations in CAS calculator. Alright, now this is an example here done before. So as you see, what we do with the calculator, we define the matrix, put the element, we store it in variable A. So you can use the same values that were in that example, and then you put them. And this is another matrix given B. So this is different example from the book, but you can put exactly the same number, and that would be the practice for you to put the same numbers. Now, how we define them is in the calculator. You go here, press on it, and matrices is one of the options. Double click. It asks you how many rows and how many numbers, so the order. So let's change that. Let's say it's a 3 by 2. Okay. Then you put it, and then it asks you to enter the element. So you put what that matrix has in it. All right. So whatever that may be the case. All right. So you fill it up, and once you have finished with the matrix, then what you do here, control store it. Okay. We want, and you don't store it inside. You see here. This is the matrix. We finished. Put it outside and say control store. So don't make the mistake putting it in the inside, because that will give you wrong mistake. Give you, if the store is here, it means store number 1 into something. Now we want to store the whole matrix into a variable, and you can pick whatever you want. Let's say A, hit enter, then now A is this matrix. Same thing. Let's say we wanted another matrix, and if we want to add them, they need to be in the same order. So again, and then you just put whatever values that one has. You put the real values from your exercise. Okay. Okay. So now if we go and put control and store, it will actually do it here and will give you wrong result. Point outside, so now the whole matrix is selected. Then go control, store, and we want this time B from what's in the book, and then enter. So now all that did is stored that matrix as A and that one as B. So now we can go and do the operations A plus B, enter, and it tells us this is the end result. So if you put here 5 plus 6 is 11, 7 plus 1 is 8, etc. And we can do A minus B, and we get the result. We can do B minus A, and we get the result. Okay? So the commutative law, it's important. Let's say it here. Say, how come A minus B is different than B minus A. Well, 3 minus 5 is minus 2. 5 minus 3 is 2. This is the negative of it. Commutative law is talking about putting negative B, putting uh, negative B, okay, plus A. And negative B plus A is the same as A minus B. Then you get the same matrix, okay? But not B minus A. B minus A is the negative of that matrix. So as you see inside, all the values have the same absolute value but the opposite sign. So here minus 1, 1, 6, minus 6. Positive 2, negative 2. Negative 3, positive 3. Totally the opposite. So this is the negative of that one. Alright? And also, you can do, if they are multipliable, then you can do the operation here as well. Now, let us finish by defining two new matrices, okay, um, from different order. So make one 3 by 3 and put the values in it. Okay, get out of it, store it into. Now, we already used A and B, so let's store it as C. Okay, and let's define a new matrix. What we're doing, I'm defining different order matrices. Okay, so we want to see what happens when you try to add different order matrices. Let's call that D. Okay, enter. Now, C is defined as this. Let's see what happens when we say C plus D. What do you think will happen? Remember, we said in order to add, they have to be same order. So if you try to add them and they're not the same order, that's what you get. Dimension mismatch. There is no result for it. We cannot add them if they have different order. Okay. So with this, we came to the end of this session. So as we've seen, our objectives were to learn about matrices, addition and subtraction. The success criteria was to have to be able to first define the matrix, understand what matrices are, to be able to add and subtract both manually and using the pairs. And we've done all of that. Now you have to test yourself against success criteria and do examples and exercises. Now, as a rule of thumb for all of our chapters, you are in control of your learning. So I can give suggestive exercises for you to do, but if you know that you are having problem with it, you haven't fully understood the concept, then do as many exercises as possible. Okay? Now, I suggest that you try to do at least one from each exercise type and to definitely try the last exercises. Okay? Now, what I'll do next is I'll put on the screen some of the exercises for you to do. They are not in your textbook. This is from Jacaranda, at least we mentioned. This is Jacaranda's Math Quest. So the credit goes to them. They have rights to it. This is for educational purposes. They still hold the rights, publishers hold the right to it. And we thank them for supplying the details for us. I'll put some exercises for you to practice, and you can also, in your book, there is a chapter on transformation, which includes matrices in it. But it takes for granted that you already know the matrices, which probably is not the case. So this is, we are doing an introduction matrices before we delve into the other textbook. Okay, so I'll just put on the screen the exercises. You can then go and capture the screen and print them, or leave it on the screen and solve it manually and practice with CAS as well. So you need to know both how to do it manually and how to do it via the CAS calculator. Okay, so that's it for us today. We'll just post those exercises and have fun with them. And if you have any questions, you can ask me in the classroom, and you can also post questions online. Okay, here are the exercises. So as you see here, when you have this symbol, it means this is calculator free, so you have to do manually. Send here and there. And normally, as you go, they become harder. So do as many as you want, but don't go and say, no, it's too easy, I don't want to do any practices. No, do some practice. And what you can do, you can verify, since you don't have the solutions at the back of the book to verify whether you've done it correctly or not. To verify, you just do it then in the calculator and you get the answer. Okay. Uh, Now, in some of them, they talk about solving equations and finding variables. We will be covering that next, but for now, if you don't remember from previous years how to solve the equations, equations, things like that, you can leave it for now, and we'll discuss it later. Otherwise, feel free to attempt it, and definitely try to solve the later ones. Okay, so you can freeze the screen here and write the equations and solve them in your booklet. And this is the continuation of it, and it finishes at question 13. Okay, so this same work will also include the next topic we will talk about, which is solving equations before we move to multiplying matrices. Okay, so enjoy. Till we meet again, I bid you farewell.